Good afternoon. I'm Ben Hunsberger, and I'm here with Bruce Bagwell today to
Hi.
talk to you about GemStone. Bruce, what are you going to show us?
I'm going to show you a GemStone document we received from one of our collaborators, Sam. And by doing that, we'll see how the program works.
That sounds great.
This is the email that Sam sent us, and this is a B-cell bone marrow, and it's 11-dimensional data. So I'm going to double-click on the document that was attached and click OK.
Now, Bruce, can I run this on my Macintosh?
Absolutely, and also these documents are cross-platform compatible.
Okay, great.
We'll click on OK, and we'll see essentially what Sam was looking at before he sent it to us. The key part of these documents is this overlay right here. What you're looking at are all the correlations of all 11 measurements on B cells as a function of their progression in bone marrow. So for example, on the left side here, these will be representative of B cells that are very early in their development, and on the right side are B cells that are very late in their development. On the y-axis we have relative intensity, and this simply shows you the intensities of all the measurements that are being made as a function of progression.
And I have one ribbon, one band for each of the markers that was measured?
That's correct. And let's take one for an example just to understand what we're looking at. CD20 is normally upregulated towards the end of B-cell progression. So here we can see CD20 is negative, and then all of a sudden it's upregulated right here, and you can see it come up, upshoot a little bit, then come down. At exactly the same time, we can see the upregulation of CD45 and also the upregulation of both kappa and lambda.
Okay, so there's a lot of correlations there. Now, I'm seeing that kappa and lambda are broadening as a function of the progression. Is there a meaning there?
Right. That's another piece of information that's being shown in this graph is the width of these bands is proportional to the amount of variability in the data. And in this particular case, for these kappa and lambda light chains, this variability is due to the heterogeneity of the data itself.
Okay. Now, Sam chose the colors for these bands, or where did they come from?
Well, you can choose the colors of the bands, but it looks to me like what Sam did here is used a feature in the program that shows the colors as the fluorescent emissions of the fluors that are on the antibodies.
Okay, so it's matching what the instrument was detecting.
Right. So another piece of information that's shown on this graph is the percentages of each one of these stages can be read directly off the progression axis. So for example, the early B1 stage is approximately 4 or 5%. You can just read that from the axis.
So how did Sam put this model together?
Let's take a look and see what Sam did. In order to put this system back into the same state it was when Sam started, we're going to go ahead and click this option, and we're going to turn off all the match status flags.
Okay, looks like pretty much everything disappeared when you did that.
That it did. The next thing that Sam did was he turned on CD19 in order to see just B cells in the bone marrow. So I'm doing that right now.
Okay, and I'm seeing our bands are back, but they are all horizontal bands in our overlay.
That's correct. They'll continue to be horizontal, Ben, until we actually start looking at measurements that vary as a function of progression.
Okay.
We're now going to, what Sam did was he cleaned up the data by looking at low light scatter, which is just the lymphocytes that are now expressing CD19, and I've turned that on.
Okay.
Things get interesting now when we look at a marker that actually changes the function of progression. So let's look at CD20 as an example. This is what Sam saw when he first started. And you can see that there are some cells that have very little CD20 and then some that have quite a bit.
Mm-hmm.
And what Sam knew was that CD20 is upregulated in B-cell development. So he used what we call a step-up, and he simply position these control definition points to approximately where they are now and hit the estimate button.
Okay.
And we'll go ahead and do that right now by turning the
Now
match
we're
on.
starting to see a lot of changes over in our plot now.
You sure can. And the analogy I like to use, Ben, is that this is like a crossword puzzle. In fact, it's a very simple crossword puzzle. Once you have one answer to the clue, then really all the other answers to all the rest of the clues become more and more evident, as you can see. Already we're starting to see that CD10 is downregulated, 38 is downregulated, 45 is coming up. All that information is now obvious as soon as we modeled CD20.
And it's all coming from that CD20 part of the model that we're getting at.
Exactly. So what happens in this system is that as you go through it, you start with what you know, and then very quickly it shows you even markers that you don't know anything about.
Sounds like a great exploration tool.
It is. Let's now look at what Sam probably did next, where he looked at CD34, and he knew that CD34 is downregulated early on, and he used a step down, and as soon as he hit the estimate button, he could see the rest of the correlations in the plot.
So do we need to really to model the remaining parameters, or are we all set at this point?
We're pretty much all set. What we normally do is do a few more in order to just refine the model. So for example, if we come down to CD45 at this point, we already can see that CD45 increases in 3 levels. But as soon as we add this to our model, I think you'll see that everything becomes a little cleaner and crisper as to where all the transitions are occurring.
I see. I noticed some of the ribbons got narrower too.
That's one of the aspects or characteristics of this software, is that as you add more and more parameters or measurements to it, it gets better and better. The last one we'll show you is that he probably did CD10 next, and again, as you can see, it obviously is in 3 levels here, and then when he modeled that, the system got even better.
Well, Sam looks like he's done a pretty good job on this, Bruce.
Well, he should have, since he came and received our 2-day workshop and learning how to do this modeling.
And that sounds like that's probably a good idea to...
It is. It's an intense time, but it's the great state of Maine, and you'll learn all about how to do this modeling. The other thing I wanted to show you is that if we look at a typical bivariate here of 10 versus 20, you can see that each of these stages is being represented with the colors of the dots. But you also can see arrows indicating the progression of the model through the data. We can add to that and add a little motion to it by turning on our animator, and we'll go ahead and do that now. So here you really can see the relationship between the model and the measurement space.
I see.
So what you're looking at are 11-dimensional space, and we're looking at B cells as they develop in bone marrow. And I think to answer Sam's question, I thought he did a great job.
It sure looks like it. So how would somebody get this if they wanted to try this at home?
The easiest way is to go onto our website, which is vsh.com, easy to remember. And if you go to the home page and click on the GemStone product, you can read all about it, and we have videos and tutorials that you can look at as well. And the thing you should do is just click on the try before you buy option.
And with that, I could go ahead and open up Sam's model and work with that.
That's right. We actually have Sam's model on the website, so you can look at it just the way we just did. And we have a number of other documents as well.
Oh, that's great. That sounds great. Thanks for taking us through this today, Bruce.
Thanks, Ben.
He's getting there.
That was good.